Okay, this is our last of the basic factoring methods that I use, and this is number 7. This is the sum and difference of perfect cubes. Now, we won't really derive this by multiplying it out. We could multiply this, and I'll show you that in just a second. But if we've got the sum of perfect cubes, then this is kind of a rule, and you can think of it as a rule. We know that it will factor to be the product of a binomial times a trinomial. Now, here's some perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. 6 times 6 is 36, times 6 is 216, so that's 6 cubed, and 7 times 7 is 49, times 7 is 343, so that's 7 cubed. So these are some of your perfect cubes. All right? So if we've got the sum of perfect cubes, we know that this will factor to be the product of a binomial times a trinomial. We'll never see that. Sum or difference of perfect cubes. Okay? So we just have to figure out the SIGNs, the signs in here, because we're going to have 2 signs here and 1 sign there. So there's an easy way to remember it. We know that if this is positive, this sign is going to be the same. All right? So if this is positive, that's going to be positive, so that's going to be the same. And then this sign here is opposite this sign. Same, opposite. And this sign is always positive. The last sign is always positive. So those are your 3 signs. This is the same. This is the same right here. This one's opposite. And this one's always positive. Same, opposite, always positive. Okay? So over here, this sign will be the same. The sign will be opposite. And this is always positive. You see? Real easy. Now there's an easy way to remember that. Look at the first letters. Same, opposite, always positive. And that spells what? Same, opposite, always positive. Soap. So we use a little soap on this. Okay? And then what you do is you just identify the cube root. So the cube root of a cubed is a. The cube root of b cubed is b. And these numbers go right in here, a and b. So let's just transfer it. And then we've got a squared here and b squared there, which looks a lot like the parts of a trinomial square, except instead of having twice the product, we just have the product AB. And that's your formula. And for this one, the same idea. A, B, and these go here. A goes here, B goes there, A squared goes here, B squared goes here, and then just their product. A, B in the middle. And there you go. It's not twice the product because then we factor, but it's just the product. So it looks almost like a trinomial square. If this was a 2, it'd be a trinomial square. If there was a 2 here, excuse me. Okay? So let's see some examples, and this is sum and difference of perfect cubes. It's really easy as long as you remember SOAP, and you remember that it's a product of a binomial or trinomial. So you can watch how I do these. So let's take a look at the first one. So I look at example 1, and I know that the cube root of x cubed is x. So I'll write that up above. And the cube root of 64 is 4. 4 times 4 is 16 times 4 is 64. So I know that this is the sum of perfect cubes, so I know that that will factor to be the product of a binomial times a trinomial. And then I have to put the signs in, so I'll use a little soap. Same, opposite, always positive. And then what goes here, x. What goes here, 4. What goes here is this squared, x squared. What goes here is 4 squared, which is 16. And just the product, 4x in the middle. 4 times x in the middle. Let's try another one. Again, there's cube root of x cubed is x, and the cube root of 8 is 2. So I know that this will multiply to be the product of a binomial times a trinomial. So I'll write my binomial and a little bit more room for my trinomial. Then I'll put my signs in. And I know this is going to be the same, so this will be negative. Opposite, always positive. And then this is going to be x here, 2 there. These little numbers go right here. And then this is this one squared, first term squared. And this is going to be 4. And this will be just the product of these two numbers, 2x. Now, if you multiply this out using 6 multiplications, it will simplify to be this. Okay? You can try that. Multiply x times x squared, x squared, and negative 2 times each of these. So you have 6 multiplications. 1, 2, 3, 4, 5, 6. If you multiply those out, you're going to get that. If you don't believe me, try it. Okay? Next one. 2x is the cube root of 8 and x cubed and 5. So those are my cube roots. So I've identified it as the sum of perfect cubes. So I know that this will factor to be the product of a binomial times a trinomial. So I use SOAP for my sign, same, opposite, always positive. And then I just put 2x here, 5, and then 2x squared. So that's going to be 4x squared, square that, 25, and then just the product. That's just going to be 10x in the middle. Okay. And example 4. The square root of 216 is 6, so that's 6x. And the square root of 343 is 7, so that's 7. Not the square root, excuse me. The cube root of 216 is 6x. The cube root of x cubed is x. The cube root of 343 is 7. And the cube root of y cubed is y. Pardon me. So we know this is going to be the product of a binomial times a trinomial. So the signs are going to be the same, and then opposite, and always positive. And these little numbers go here, just 6 and 7x, 6x and 7y. And then here is going to be this squared, so that's going to be 36x squared. And this is going to be this squared, little number squared, so that's going to be 49y squared. Oops, you can see the square there. And then we're going to have the product with 6 times 7 is 42 in the middle. 42xy. Sorry about that. I had a little mishap there. Ran out of room. Didn't plan ahead. I have plenty of room too. Okay? So you just have to remember the forms. It's very easy. You just have to know your cube roots or your perfect cubes either way. I think you have some homework problems like these. That's a little bit better, I hope. So that's 49y squared. Put the parentheses over there. There you go. So something like that. Okay? Hope that all makes sense. That's factoring method 7. So take a look at those examples. That should be pretty easy.